So fog computing, an overview, what problem is being solved, what is fog computing, history of fog computing, cloud computing and its limitations, need for fog computing, and fog computing architecture. So for what problem is being solved, cloud computing requires a huge amount of bandwidth to serve the connected devices that make up the Internet of Things. What is fog computing? Fog computing is an architecture that carries out a large amount of computation, storage, and communication using edge devices which communicate locally and are routed over the Internet. Fog computing is also known as fogging or edge computing and is a model in which data processing and applications are concentrated in devices at the network edge rather than existing almost entirely in the cloud. Fog computing is not a separate architecture and it doesn't replace cloud computing, but rather it complements it. It's used with it. The link between the cloud and the Internet of Things, as you can see from the diagram, fog computing is right between the cloud and the Internet of Things. The history of fog computing. The term fog computing was introduced by the Cisco Systems as a new model to ease wireless data transfer to distributed devices in the Internet of Things network paradigm. In 2010, the need to extend cloud computing with fog computing emerged in order to cope with the huge number of Internet of Things devices and big data volumes for real-time low-latency applications. Cisco introduced its fog computing vision in January of 2014 as a way of bringing cloud computing capabilities to the edge of the network and, as a result, closer to the rapidly growing number of connected devices and applications that consume cloud services and generate increasingly massive amounts of data. On November 19th of 2015, Cisco Systems, ARM Holdings, Dell, Intel, Microsoft, and Princeton University founded the Open Fog Consortium to promote the interest and development in fog computing. Here are some limitations of cloud computing. It uses high capacity or bandwidth, client access link, high latency, and security issues. The need for fog computing. Fog computing is an extension of cloud computing and brings it closer to the network devices. Both use the same resources such as storage, networking, computation techniques, as well as many other resources and mechanisms. As time goes on, more and more people continue to buy smart devices. This means that many devices in a person's everyday life, phone, tablet, computer, game system, refrigerator, house, lights, etc., all will connect to the cloud when receiving data. Cloud computing has a high latency, high downtime, and security and privacy issues, along with requiring a lot of bandwidth. To overcome the drawbacks of cloud computing, we need a technique which gives a solution for all the above-mentioned issues. Fog computing architecture. The fog computing architecture is the arrangement of physical and logical network elements, hardware, and software to implement a useful Internet of Things network. Fog computing is a recent concept and there is ongoing research on its architecture. There have been several proposed architectures for fog computing, some of which are listed here. Fog layered architecture. Hierarchical fog architecture, open fog architecture, fog network architecture, fog architecture for Internet of Energy, fog architecture based on the nervous system, integrated fog cloud Internet of Things architecture. Implementations of fog computing. How does fog computing help? Reduces data movement across the network, resulting in the reduction of congestion in the network, elimination of bottlenecking, resulting in a centralized computing system. It also increases the security of encrypted data because it stays close to the end user. Rather than one centralized location that may become vulnerable, activity takes place between various local endpoints, making it easier to identify threats such as infected files, potential hacks, or malware. Fog computing helps improve productivity and increase the speed of business processes. The limits of fog computing. Complex architecture. The whole concept of fog computing seems complex, a system that includes many devices that store and analyze their own data that could be localized anywhere at any time adds complexity to a network that once sent all of its data to a centralized location. Risk. With numerous devices and therefore numerous users, the risk for corrupted or infected files, apps, or information leaking into the company's main data stream dramatically increases. Not economic. Power consumption is high in fog nodes compared to the centralized cloud architecture. Scheduling. It is complex because tasks can be moved between client devices, fog nodes, and back-end cloud servers. Security issues. Encryption algorithms and security policies make it more difficult for arbitrary devices to exchange data. Consistency. To achieve high data consistency in the fog computing is challenging and requires more efforts. And that's it.